Welcome back after the coffee break. I hope that you're refreshed. I hope that you're in a good mood. No, I know that you're in a good mood, both here in the room. I see some smiling faces. That's great. Thank you very much for that. I hope that you're also behind the screens, wherever you are in the world, that you're also smiling, that you had a great time already with the panels, with the discussions that we had today in the morning. Apologies for the sound issues that we had. We hope that now for the next virtual participants, this will work better. But you know, we are in a virtual environment, and virtual environments are not always fail-safe. But let's see how it works. The good thing is, I see already that two of my next panelists are already connected, and the third one is already here in person, which is great as well. So without any further ado, let's jump right away into the next panel discussion, which is titled Preparing for the Era of Quantum Networks. And for this, I have with me virtually and in person, I have three people. First of all, Professor André Xuereb, Head of Department of Physics of the University of Malta. André, very warm welcome. Ooh, that's a coffee break, actually. You don't find your words after the coffee break anymore. A very warm welcome for André, and also for Dr. Christoph Pacher, Senior Scientist, Austrian Institute of Technology from Austria, as well connected virtually. And then here in person, Alain Kuresevic, Managing Director of SES TeleCom from Luxembourg. Welcome to the three of us. I'm going to hand over right away to André for a short introduction about what he's doing and what he would like to speak about in this panel.
Thank you. Thank you so much. It's a pleasure to see my colleagues here. I'm sorry I couldn't join in person, but you know, pandemic is what it is. Right, so I have some slides here. I'm not sure if they're...
The slides are showing. Okay, everything is good.
Thank you so much. Right, so I am André Xuereb from the University of Malta, and I'm also Ambassador for Digital Affairs for the Government of Malta since the beginning of this year. And I'm here to talk about quantum communications, just to give a very, very brief introduction to why it's interesting, why we do what we do effectively, and why we think it's the future. I'm not going to dwell too much on the details, but of course I'm more than discuss anything after the discussion. Right, so to go straight to it, we have an issue coming up in that our communication systems are actually not secure. If there is a country that develops a general purpose one computer, for example, or there are some other advances in computation that we're not currently aware of, then our communication systems all can be compromised. And this is a problem because, of course, we rely on the security of these communication systems in order to communicate securely and safely and keep our data safe. So there is an issue there. And this is one of the issues that quantum communications tries to solve. Now, those of us who are not cryptographers, here's a very, very, very brief introduction to how cryptography works. So let's say there's two people, Alice and Bob wants to send a message to Alice secure. Then Bob needs to find a way to lock that message, encrypt it somehow, turning it from something readable to something which is completely illegible to someone who doesn't have the right key. Sends that message, the garbled message, to Alice, and then Alice, using some sort of software, decodes this and obtains the original message. This is effectively how cryptography works. Now, there is one detail here which is critical, and that is how do we garble the message and how do we give Alice and Bob these keys in order to perform this communication? So, there we go. Waiting for the slide to, oh, there we go. Yes, so the first way in which this is done is called symmetric cryptography. And that's where Alice and Bob use exactly the same digital key to encrypt and decrypt, and this can be absolutely secure. But it also means that we somehow give Alice and Bob this key. And there are people checking physical keys in briefcases to make this happen. So this is something we still use, but of course it's impractical for us who want to buy things, for example, or banks or anything. The alternative is cryptography, where else is different. Now this makes it easier to give them the keys, but it is in principle possible to reverse engineer everything and break into the communications. And this is the Achilles heel of the internet. This is the big problem with cryptography. Now, what quantum key distribution does is effectively allow us to, in hardware, distribute keys to allow symmetric encryption to happen in a way which is practical, in a way which can be used by organizations all over the world. So basically allows us to change the way we talk to a way which is completely unbreakable. And just to end what's going on at the moment, there is something called European Quantum Communications Infrastructure, EU, QCI, Luxembourg, Malta, and basically every European member state is now a member of. And what we're working on is a medium-term plan to be able to set up an infrastructure of a sort that allows European countries to communicate securely in this next decade or so. And that's the introduction. I'm happy to any questions or discussion ideas.
Okay, thank you very much. Let's head over right away to Christoph. Maybe from your side also a short introduction, please.
Yeah, hello, good morning. My name is Christoph Pacher. I'm with the Austrian Institute of Technology, and for the last 15 years I've been working on the field of quantum cryptography, on theory and also on QKD system design and QKD networks. And since very recently, I'm CTO at the Austrian SME Fragmentics Storage Solutions, and there we concentrate on securing data at rest, which complements the activities on QKD, which secure data on transit.
Okay, thank you very much, Christoph. Alan, your turn. Yes, it works. Yes, now it should work.
Now? Okay, thank you. Good morning, everyone. It's a pleasure to be here today. My name is Alan Kuresevic. I'm the managing director of SES Telecom. SES Telecom is the 100% owned company of SES Group, the major satellite operator in the world, the biggest satellite operator. We are actually the unit that takes care of the new technology development and translating this technology into the commercial space. And quantum key distribution over the satellites, over the space segment is one of the key topics we are working these days and engaged since basically a few years now, and looking forward to launch the first satellite actually that will demonstrate this in the space.
Okay, perfect. Maybe as we have in the audience, not everybody knows exactly now what quantum networks are. Maybe it would be a good idea just to give a quick overview still also about the definition of a quantum network. Christoph, can I ask you maybe from your side to jump in here and to define quantum networks so that we non-technicians, I would say, non-scientists actually understand better what it is?
Yes, it's my pleasure. So the difference between quantum communication and classical communication is that you have quantum bits, and quantum bits can be in a superposition of 0 and 1. So you can have an infinite amount of information basically because it transmits zeros and ones at the same time. This is also the principle of the quantum computer. So a quantum network is basically a network where you transport quantum information. And this is, I mean, this can bring really a revolution in how we manipulate and calculate with information. And one of the very first applications of quantum networks is what André explained, is quantum cryptography, where you send quantum information through fibers or space to exchange quantum information and create secret keys. And so a network which consists of nodes and fibers connecting these nodes is basically a quantum network.
Okay. I think that's the definition that everybody now can understand. Which brings me also, you mentioned satellites. Of course, then I'm heading over to Alan. Because Alan, what have we learned now from the world's first quantum communication satellites? What are the experience that you have made? What can we take out from that?
Actually, there was the first quantum key distribution done by the satellite, by the Chinese satellite, so non-EU kind of experiment, which some of the EU countries participate in that as well. The key in satellite usage in that technology is that the fact that you can only transmit the quantum information for the very limited distance using the fiber optics due to the very low energy that photons create. Quantum communication is actually using to transmit information. So in order to actually expand the quantum networks for the larger distances, you need a satellite. So basically, you need a satellite to bridge any points that are probably more than 100 kilometers apart from each other. So in that respect, satellites will play the key role in bridging the long distance, let's say, quantum needs, both on the quantum cryptography as a key distribution medium, but as well in the future as a quantum network medium to transmit the quantum information from one place to another.
Okay, thank you very much. I'm heading over to André. We have a little bit sound issues. I'm not sure if it's because of your headset that you're using, but we're going to give it a try. I hope it works. Maybe from your side also, how can a quantum network address challenges around security and privacy? You showed it already in your presentation briefly, but maybe we can detail and dive into this topic a little bit more, especially to see how this can be solved.
Sure. Can you hear me well?
For the moment, it works. It would be worth trying maybe that you take off your headphone, but let's give it a try now like this.
Let's see. Okay. Okay. So basically, as Christoph just said, quantum networks send quantum information, quantum bits. And one of the fundamental things about quantum information, quantum bits, when we compare it to ordinary bits, is that they can be in two different states or more than one state at the same time. And this is critical because this magical property is very delicate. If anyone tries to observe quantum bits whilst it's being transported, then it will collapse. This property will disappear. Now, if we have a network that allows us to distribute quantum bits. We run programs which use the quantum properties of these quantum bits to create a security which allows us to use symmetric encryption, which is unbreakable. And if there's anyone in the middle who's trying to eavesdrop the communication or trying to break into it, then this will this quantum property, and it will alert two sides that the link has been compromised. And even if they tried the resulting information to communicate securely, they wouldn't manage. So this is a kind of the universe keeping communication systems secure using quantum properties.
All right. Thank you very much. Still, we have sound issues. Maybe what you could try is just to take another headset eventually, or use a microphone from your laptop. Maybe that will work better. So that's
because I'm at the airport. I only have this one.
Okay, but on your laptop you might have a microphone, so you switch simply the microphone. We're trying. But over to maybe Christoph in this case. Christoph, we speak here about a technology which is pretty new. I mean, quantum computing itself is something which is really at the beginning, I would say, of the development and very far away from something which can be deployed in public. How about quantum networks? Any time frame that we could see when this can be deployed, really, that we have really the first usage, really? I mean, we have seen satellites already operational, but still broad public usage.
Yeah, so there is in Europe, there is an initiative on building up a European quantum communication infrastructure. And the roadmap for this infrastructure is that approximately in 5-6 years, we will have the first network rolled out in Europe. also at the same time, already the first satellites, the first European satellites should have been launched, working together with this terrestrial quantum network. And the first use case would be to connect governmental sites in Europe.
Okay, so it's actually faster than I expected it. So it's not only in 10, 15 years, but it's in 5, 6 years where we're going to see the first results, kind of. Question to you, Alan. How can now the different sectors utilize quantum networks? And especially also when it comes to that, what are the problems, what kind of problems will they solve when it uses quantum networks?
Yeah, the initial deployment of quantum networks, which is really focused on the quantum key distribution, is actually solving the major threat of the cybersecurity for the future appearance of the quantum computers. And it's true that, as Christoph said, the networks will come maybe in 5 years from now, while the quantum computing on the general scale might not be available yet at that point. However, we are facing the threat of store now and decrypt later. That means basically any data which is generated today and being of high value and being stored can be actually decrypted at the time the quantum computers are available. So there is incentive for governments, for the critical infrastructure operators, for the hospitals, banks, to actually use that facility that is provided through the quantum key distribution and secure encryption already much in advance of the appearance of the quantum computers, as to avoid the data stored in the meantime to be actually vulnerable to the cybersecurity attacks at the time quantum computers come across.
André, I see you nodding quite a lot, so that obliges me almost to head over to you and to see what you can contribute also to this part.
Sure, thanks. So a couple of things. First of all, just to add to what Christopher said and your question to him. Yes, we're looking at 5 to 10 years perhaps as a horizon for large-scale satellite-enabled QKD systems. But there are quantum key distribution systems on the ground, even available commercially nowadays. So, the future is now in some sense. Also, I was nodding because this store now decrypt later attack, which I didn't mention in my very brief introductory remarks, but which has just been mentioned. This is actually one of the most worrying parts of the story that I was trying to tell, because we have a situation where data that's being transmitted nowadays, which we think is safe, because it's safe with respect to computers that we have nowadays and all computation power we have nowadays, that data can be stored for 10, 15, 20 years and be decrypted later. And there's no way to stop this unless we use QKD or similar mechanisms. So it is a very, very important thing to guard against, something which quantum is uniquely suited to help us with.
Okay, thank you very much, André. Christoph, question to you also. Where do you see the challenges now and the solutions for creating the next generation of quantum communication, especially now when it comes to short-term and the long-term benefits?
Yeah, so in the short term, I think challenges in the field of quantum cryptography would be in the field of standardization and certification, because this is necessary for a rollout for cryptographic applications. In the medium to long term, if I think about quantum internet, I think the main challenge is in making quantum repeaters. That is a technology that allows to distribute entanglement over basically arbitrarily large distances. And this allows us then to connect quantum computers throughout Europe to build really a distributed quantum computer. So this would be really the long-term challenge. Also combining this with entanglement distributed from satellites. Okay.
Alan, question over to you. I think you mentioned also in your short introduction the QCI project, so the Luxembourg Consortium for QCI project. Can you just dive in a little bit more about this, the involvement, and also maybe detailing what it is?
Yeah. Luxembourg QCI is actually a national initiative, Luxembourg national initiative to create the first QCI network in the country. And it's a part of the overall, let's say, action plan for the EuroQCI, European Commission initiative, which looks at the federated system of networks, which each member state will have its own network, sovereign network, but being connected in the one European-wide network to basically interoperable and interconnect with different member states. So SES, together with other Luxembourgish partners, are leading that project together with Ministry C in Luxembourg, the SMC, in order to create the first instances of that terrestrial network, and ultimately, in the time frame of 2024, connected to the first satellite, Eagle 1, that will launch to be actually first network in Europe to be hybrid satellite terrestrial QCI network, available for testing and obviously for commercial deployment as we progress further.
Mm-hmm. Over to you, André. What about the Euro QCI?
Sure. So as we just heard, the QCI is an initiative happening in all member states where we're building these national quantum-safe networks. And what EuroQCI is doing is making sure that we're all working at the same speed, all working together, so that over the next 5 to 6 years, we will be able to start interconnecting these networks together, and by around the turn of the decade, be able to have one single ultra-safe communications network spanning the European Union. And this is what the EuroQCI is all about.
Okay. Now, let's move a little bit more to a global scale. When I look at quantum computing, I see that mostly American companies seem to be quite at the forefront. Google is operating a quantum computer already, as we know. Now we hear about the quantum network. We hear a lot about Europe and Luxembourg here. How does that fit on the international scale? Maybe André or Alan, whoever wants to dive into this, or André. Up to you.
I was going to say Alan. Happy.
Yeah. Okay, I can maybe say a few. I mean, Luxembourg is definitely on the forefront, at least in Europe, if not worldwide, in that respect, especially with the activities integrated very much into the EuroQCI initiative. There are a number of, let's say, networks which are popping up as quantum key distribution networks around the world. Probably the most advanced networks today we have in South Korea, where the South Korean TeleCom actually introduced the first, let's say, commercial network in which they actually connected their 5G infrastructure to be connected and protected by the quantum key distribution facilities. We have a lot of also, let's say, non-commercial trials in China. China is definitely leading the way outside of Europe, and I think Europe is now, I must say, trying to catch up, especially on the development of the European sovereign technology, which is not obvious that it's always really exists in Europe and doesn't need to import it from outside of Europe. And I think there is a now big push and big momentum in order to kind of create the ecosystem in Europe of both technology service providers, network operators that will actually engage in that activities and have a commercially available networks in the 24-25 time frame.
Okay, thank you very much. Christoph, maybe you can look a little bit in the crystal ball also when it comes to security. I mean, quantum computing, quantum networks is something rather new also. Other technologies that we have are very approved and very stable also. When can we believe that we reach kind of a maturity which is stable enough also, or is it already stable enough that we say we can really deploy it? Not only the commercial deployment, but simply the stability also behind.
Yeah, I would say what is really important is to achieve now the standardization and certification. That will probably need 3 years or so. I think then we have the technology and can roll it out. I mean, this European quantum communication infrastructure, as I said, it's maybe rolled out in 5 years. But for smaller networks, I think we could have certified devices in 3 years.
Okay, which is a rather short time frame. So I think there is a lot of work still going on. Well, gentlemen, I have to thank you for your presence, for your information, for your insights also. It's a topic which is difficult to understand because I believe that most of the people already have problems understanding the concept of quantum computing. Quantum networks doesn't make it really easier, but again, as many of the technologies that we have been speaking here around, it's probably something which will be integrated seamlessly in our life in the next years. And I'm really looking forward to it. So far, I can say thank you to André, thank you to Christoph, and also thank you to Alan for your insights. And also from the audience, please, a very warm applause for the three of them for their insights. Thank you very much.
Thank you very much.
Thank you.
So now we are going to move over a little bit more to another topic, slightly different topic, which is going to be network spectrum innovations and alternative new complex that we're going to treat today. And as you can see, I'm remaining seated here comfortably in my armchair. I hope you at home, wherever you are in the world, you might also be comfortable. And nevertheless, stay attentive because now we're switching gears. My next panel discussion will be about how far to 6G. We have mentioned it already a couple of times before today. 6G is on the horizon. It's in the middle of the development, and we'll soon see more information about it. And today we have already information. And for this, I'm welcoming on stage, both virtually but also in person. First of all, Bernard Barany, Deputy Head of the Unit of the European Commission, DG Connect from Belgium. Ladies and gentlemen, warm applause for Bernard Barany, so please. Then we have Dr. Howard Ben, VP Communications Research from Samsung Research and Development Institute from the UK, as well virtually connected. Welcome, Howard. And then last but not least, we have Dr. Maxim Giernik. Sometimes it's, as a moderator, a little bit difficult to always pronounce the names correctly. Dr. Maxim Giernik. We're going to stick with Max. I think that makes it as well. Affiliate researcher at the Stockholm University in Sweden. A very warm applause also for you. Let's start with a short intro of Bernard and the view of the European institution and the European Commission on the topic 6G. Bernard.
Yes, good morning. Can you hear me?
Very well.
Very nice. Thank you very much, and many thanks for the opportunity to participate in this event. So my name is Bernard Barany. I work for DG Connect in the Future Connectivity Systems unit, where we have basically two missions. One mission is to support the deployment of 5G in Europe by putting in place the right framework conditions in the member states and by supporting also deployment like connected and automated mobility support through the CEF program. And our second activity is to support competitiveness of the industry through research on the programs. In that context, we are now preparing for the so-called smart networks and services joint undertaking, which is a partnership with industry, which will study in Europe 6G type of technologies and architectures. At this moment in time, we see 6G as a very important topic from several policy perspectives, policies which are supported by the Union. First of all, our so-called digital policy, which is aiming at supporting the supply side and the demand side. But we see also this important in the context of this new dimension of sovereignty, which is basically trying to improve European presence in the supply chain. And here, for instance, we have a lot of potential activities on microelectronics. The second aspect, the so-called Green Deal, where we believe future generations will have the possibility to support more prominently the sustainable development, and this is something important for us. And another policy element which is very strongly reflected in our framework the cyber framework, where we believe that new technologies and new networks will help us secure the full value chain to the cloud and to the deployment of services. So that's the overall which we are working at this moment in time. And we are working this partnership with the cooperation by the.
Okay, thank you very much, Bernard. Over to you, Howard. I think you have also a couple of slides, so maybe we can have them up. So far they are not yet, but...
Yeah, thank you. So I'm Howard Ben. I've got a long history in telecom, so I started writing the 2G standards a long time ago, 3G, 4G, 5G, and now we've started 6G. So just a quick overview of Samsung's view on 6G. So can we go to the next slide?
Slides are showing, so don't worry about this.
Okay, so first of all, every G that we've had builds upon the previous G. So 4G, 5G, they've all been built on top of each other, and 6G will be as well. So if we have a look at the numbers today, they're staggering. 4G is incredibly successful, 6 billion subscribers out there. 5G is growing very, very quickly. And we hope that 6G will follow the same trend. So if we have a look at the 6G vision, we can see some potential new services, things like totally so that's augmented reality, mixed reality. Holograms are coming along. The technology is being developed very quickly, and I see holograms. And we'll talk so far about digital replicas, and these are really going to help drive both industry and smart cities in the future. And increasingly, of course, we are communicating between the machines. So we're doing that already in 5G, and we'll do a lot more of that when we get to 6G. But of course, we have to do this in the framework of what's happening within the world today. So we're acutely aware of the green agenda, lowering power consumption, and increasing connectivity, things like virtual classrooms, which have been talked about for a long time, but with COVID, it has become a reality now. And this pushes a lot of the requirements onto the communication standards. So we're going to have higher bit rates, lower latencies. What we're also going to see, though, is a change in the network architecture. Artificial intelligence and machine learning are becoming more and more important as we're going along in time. The more data that we have access to, the better those services will become. I'll just give you a quick taster of what Samsung are working on at the moment. We are already working on extremely high-speed communications, so looking at 6 gigabits per second in the sub-terahertz frequency band. We've recently announced one of our recent trial systems. Now, I think what we have to do to put all this in perspective on timescale.
Okay, I think we have here a connection issue. I would propose that for the moment, until the connection gets better, Max, we're going to move over maybe to your short presentation also. So maybe let's have the slides from Max, and then we're going to see if the connection for Howard is improving again. He's not on 5G, that's the problem, I know it.
To roll out. So we still have plenty of time.
Okay, we have, Howard, let's give it for the moment a short break. Max, over to you with your presentation, and then we can see that the connection will work again. Sometimes it improves by itself, self-healing, you call this.
Okay, can you hear me?
Yes, very well.
Yes, so good day everyone. My name is Maxim Hirnik.
And as I said, I'm at the moment affiliate researcher at Stockholm University, but previously I worked at Ericsson Research, and I was actually the project manager for the first 6G project at Ericsson. So in my slides, I want to explain a little bit how the generations of technologies are evolving and put into perspective how the development of 6G, how the timeline could look like. So the first slide shows the life cycle of a generation. So it all starts with science and research, and basically we are researching first for technology components that improve wireless communications. And this is usually used a lot of input from academia and is done within projects often funded by European Commission. Then this follows by the systemization phase. In the systemization phase, these identified technology components are gathered together into a radio access network, and also the enablers for these technology components are investigated and provided. These two stages are usually, as I was saying, involve academic input and are within projects funded by European Commission. For the 5G, it was the METIS project, the flagship project for 5G. And for the 6G, there is a project called HEXA-X that is also a flagship project funded by the European Commission.
Yeah, I'm talking, so...
Good. How are we hear you?
Okay
so
now?
It seems much better now. So it's good. We have seen you at the beginning at least, so we know how you look like. Now we have your sound, which is better. Let's continue with Max for the moment, and then we're entering the Q&A, so then you can actively participate again. So hopefully it's more stable then.
Yeah.
Okay.
So as I was saying, Europe usually leads in these research initiatives. After this, what happens is that the ITU, International Telecommunication Union, investigates and sets requirements for the technologies to be called the new G, and also evaluates the proposed technologies, whether they meet the requirements or not. And the standardization phase starts a little bit later, but it runs in parallel. And during the standardization phase, companies provide their innovation and research results to test, evaluate, and select for the published specifications or standards that contain the blueprints of the actual system that will function and meet the ITU requirements. And at some point, of course, the industry picks up with the implementation and the commercialization phase starts. So first you develop test beds, and at some point you can demonstrate certain features of a potential new systems. Then there is a trial service, usually that is showcased at some high-profile, large-scale event. And after that, there is an initial deployment and a nationwide rollout. And of course, the standardization and research does not stop there. It continues, so new technologies are evaluated and added to the standard, and new releases are pushed, so the evolution of the generation comes. And then at some point, there is a point when there is no sense to have the backward compatibility with the initial designs, and there you have to stop and redesign the system from the scratch. That's when the new generation comes. So if you would think about the 6G timeline, it would look something like this. The initial research on technology components has already started, and then there is also this first project, HEXA-X, that I mentioned, the flagship project funded by the European Commission. At some point, there will be the 6G requirements, work for specifying the IMT 2030 requirements, and the 6G standardization around release 19 or release 20 in terms of 3GPP releases. In 2026, there will be Winter Olympics in Milano, and by then there should be usually some initial demo, and by 2028 there will be Los Angeles Olympic Games, where some trial service will be showcased. And in the middle also, I would like to point out that there will be World Radio Communication conferences, and these are the instances where we discuss spectrum issues, as mentioned by Eric Fournier before.
Okay, thank you very much. Question for you, Bernard. How do you think that 6G will potentially contribute to the EU political agenda?
Yes, thank you very much for the question. I tried to answer that already in my introductory statements. We see, first of all, that each and every generation comes with basically two legs. One leg, which is basically improving the capabilities of previous generations. So 5G increased the capabilities, the broadband capabilities of 4G, but came with some very new features which were related to the low latency type applications. People talked about the tactile internet at the beginning of the 5G journey. So we see similar things happening with 6G, that they will bring basically new capabilities, and Howard mentioned already a couple of those in the context of immersive environments, in the context of holographic communications, or in the context of digital twins, for instance. But they will also improve the capabilities of the vertical industries, which is something which we have already initiated with 5G. So this vertical industry digitization, in our view, will largely contribute to the policy agenda, which is primarily digitize the society and the economy. So we see this as a further move in that direction. We see as an opportunity for Europe to reconstruct part of the value chain we are potentially missing today. So we start with the premise that Europe is strong in connectivity. It has top class of global suppliers of technologies, but they are less advanced for what concerns cloud-based platforms. But with the advent of edge cloud platforms, we see here opportunities to regain some grounds in Europe. And at the other hand, from the perspective of device, if Europe is not necessarily strong on smartphones these days, this is a statement, we see the advent of IoT with all sorts of potential connected devices, cars, trucks, as an opportunity to reconstruct something in the device, which in turn has some impact on the microelectronics industry, which is by policy agenda at this moment in time. So this is from the competitiveness perspective. We see also as a big opportunity to contribute to our policy agenda by supporting the greening of the platform itself, and there are technological routes that get investigated in that direction, but also supporting the greening of use cases which are running on top of the 5G, 6G platforms, with connected cars, where you could imagine by optimizing the journey of cars, also optimizing electricity, petrol today, consumption, which has an impact on the city. But there are also other development goals that we look into. For instance, affordability of technology, global access. Think about the satellites now, more and more about the NTN, terrestrial networks, which potentially provide possibilities to access the structures from marine, which are economic, not viable for infrastructures. We see also that moves such as Open RAN mentioned before, is the massive cloudification, softwareization of networks, potentially possibility to lower the market barriers by lowering the cost of the technology, which again provides possibilities for wide technology in regions. These are some
Bernard, sorry to interrupt you, but we are starting to lose you as well with the sound, so it's very difficult to understand what you're saying. I would propose that also from your side, you switch off the camera to save some bandwidth. Let's give it a try. If you switch off the camera, then we're going to see if it works better, because I don't want to miss actually what you say, because it's very interesting. So let's see if now it's improved. So just keep on speaking now.
Yeah, I just basically finished. I said that from the perspective of sustainability, be it the Green Deal or other sustainable development goals, which are affordability, access to the technologies, we believe that 6G has a role to play, and we can see some technologies potentially contributing to the lowering of the cost of the technology by massive softwareization of infrastructure, for instance, which are potentially supporting these policy aspects of deployment and access networks even in remote places.
Okay, thank you very much, Bernard. Over to you, Howard. Where do you think, what are the key technology advances which are needed for the moment just to set up 6G to make it running? It's a question which probably everybody wants to know. What is really needed actually for that?
Yeah, good question. So we have many technologies that are in the pipeline at the moment. If we start off with the radio, because that's where most people start, higher frequency bands, we're looking at the 140 gigahertz frequency band where a lot more spectrum is available. That gives us higher bit rates. And as we can see from the lack of video on the screen there, we all need higher bit rates. But behind the scenes, I think this is where 6G is going to be very different. So if you have a look within the networks today, we can already do machine learning, artificial intelligence, and the networks are slowly but surely getting to the stage where they should be able to run themselves. And I think this is where a lot of the enablers are being added in 5G Advanced, and that will continue when we get to 6G. So we've got cloudification of the networks. We've got more virtual networks popping up all over the place. But the key to all this is to do the technology development, but I think as Bernard mentioned earlier, to keep within that green agenda. So how do we do that without increasing the power consumption of the network? And I think that's one of the challenges that we're all working on.
Okay. Max, over to you also. We spoke already about certain applications that we can use with 6G, holographic displays and here and there. What other applications maybe do you see on the horizon where it would make sense really to deploy 6G?
You mean like use cases, potential?
Yes.
Yeah, so actually was pretty well covered by Howard previously, but of course there will be enhancement in all the use cases that 5G is supporting. In addition to that, imagine how great it would have been if there could be Howard and Bernard sitting here as holograms. So holographic telepresence and tactile communications is envisioned as use cases for 6G. And for instance, truly immersive extended reality with glasses that can stream live AR streams. But in addition to that, there will be more use cases that will be discovered as a part of this research journey. So it is a bit early to speak about some of them. They will be arising later. Yeah, that's what I can say.
Might we have also applications such as cloud-based computing where we don't carry any more very high-powered smartphones, if in 10 years we even have smartphones anymore or something completely new, or that we just have a watch simply where the main computing power is actually done in the cloud itself and we just access it over 5G, 6G then as well?
Yeah, exactly. So there could be a device that then, for instance, imagine you can use any screen in your apartment as actually a screen for your device, and it could be a watch or something, as you mentioned. Yes, definitely.
So the question maybe also to Howard, very practical question. When do you think we will be able to buy the first 6G phone?
Yes, I think that we're looking at least 2030. So I wouldn't get too carried away at the moment. So if you're planning to go out and buy a nice new Samsung 5G phone, go and do it, because it'll last a long time. So 2030 is going to be the first rollout of the networks. Probably it'll be 2031, 2032 before mass deployment is along.
Can we pre-register for it already, or is it not yet open?
Not quite yet.
Okay, maybe one last question to you, Howard. Will 6G also help the climate change agenda, and how it can help?
Yeah, this is a really big subject for us at the moment. So within 3GPP, which is the standards body that create the 5G and will create the 6G standards, there's already a focus on developments in 5G on reducing power consumption. And that's kind of building on the technologies we created for 5G about 10 years ago. So as we're creating the new technologies for 6G, we've got this already as a key priority. So it's one of the things that we'll be focusing on. But let's not forget that not only will 6G help lower the power consumption for every bit that you send across the network, but if you look at smart cities and streaming of vast amounts of data, that can be used already to lower the overall global footprint, the carbon footprint that we're emitting. You've only got to look at things like Google Maps today, and already people will drive more economically if they see there's congestion ahead, they'll slow down. All of this kind of helps the overall global footprint that we're producing. So with 6G, there'll be more data, more artificial intelligence, and that will really help us control our lifestyles to lower our energy consumption.
All right. Well, thank you very much for these insights. I think 6G will keep us busy for the next years, and I'm pretty sure that in a couple of years we're going to sit here and we're not going to have any more the Connecting Tomorrow conference as a 5G conference, but then it will be the 6G conference. I'm looking forward to it, clearly. This said, many, many thanks, Bernard Barani, for being here with us. Many thanks, Dr. Howard Ben, and many thanks also for being here on site, Dr. Maxim Girnik. Very warm applause. Welcome. Very 1, 2, 3. It's the last day, so now I'm stumbling over it. A warm applause for them, please. Well, let's move over to our next part. And now we are going to speak about light. Why light? Very simple. We have been speaking the whole time over wired connections. We have been speaking the whole time over radio connections, 4G, 5G, 6G now. And now we are going to speak about communication through light. And for this, I welcome on stage Marc Fleschen, the founder of 01 Lux SAS, the chairman of Light Communications Alliance ASBL. Marc, welcome.
Thank you. Good morning, everyone. Thank you very much for receiving me. And today we will talk about light, Li-Fi, and the light communication. I guess there is some slide decks. Thank you. Thank you very much. So today we're going to talk about light and light communication and the alliance, which is established in Luxembourg. But before talking about what is Li-Fi and what is the role of the Light Communication Alliance, let's talk about a little bit more about why do we need Li-Fi. And one of the topics that has been discussed during these 3 days of conferences are about 5G and communications, but we already also talked about security through quantum key distribution. We talked about 6G as well and the need for connectivity. And one of the facts is that we realize that the race between the pace of technological advance and the need for bandwidth is never going to stop. And the proof is we just had a conference about 6G, and we are currently talking about implementation of 5G. So it actually means that there is always a need for a faster, more secure communications layer. But today we also face challenges that we didn't necessarily face many years before, such as sustainability, security, and health concern. And if you want to keep the pace of the technological advance and the communications needs, it can't come at compromising over different situations such as security, health, or even energy savings. And towards that, light communication is, alongside other technologies, willing to play a large role in being able to bring a new layer of communications complementary to existing ones in order to expand the spectrum of frequencies. For example, today we rely on radio frequencies, but there is an existing layer of communications which is light spectrum. And the Light Communication Alliance has a large ecosystem of companies working towards visible and invisible light communication spectrum in order to be able to bring an additional existing spectrum that is being already put in place, for example, through LEDs. LEDs has been one of the enablers of the infrastructure because we rely on visible light through LEDs. The history about the LCA, we published through different initiatives a first white paper in 2018 over 5G and beyond communications, implementing light communication and Wi-Fi into 5G networks. We created officially the Luxembourg ASBL in 2019, thanks to the support of the SMC and the Luxembourgish ecosystem. The light communication has a very dedicated mission to promote, educate around light communication and Wi-Fi. It means about its use cases. We publish white paper. We help people understanding the taxonomy that is sometimes a little bit complicated to understand about the different technologies. And our role is to gather and to be an inclusive ecosystem of several different partners, as you can see on the list, that will aggregate a larger European ecosystem that is actually very active currently, and will allow us to promote and expand light communication overall. The membership for the Light Communication Alliance is, as I explained earlier, largely inclusive. It doesn't necessarily only concern Wi-Fi or light manufacturers, vendors, but it's actually wider. It's a one-stop shop for people who actually are looking for an extensive new layer of communication. So we partner with, for example, quantum key distribution people. We also partner with lighting manufacturer. We also partner with system integrator, system manufacturer, solution provider. You don't necessarily have to be purely in manufacturing hardware or light products to be part of the LCA, but the ecosystem is actually much wider to provide an end-to-end solutions. And we have also universities, scientific committees, and professors in order to already work for the next generation. Part of the LCA is to work alongside also other authorities, such as 3GPP, ITU, IEEE, but we also have MOU in place with the Ethernet Alliance, smart building like CABA, and other authorities in order to integrate seamlessly light communication alongside Wi-Fi, complementary technologies together so that they actually work, and each of them dedicated to a specific use case or specific KPIs. In order to understand a little bit more about what is Wi-Fi, it's wireless optical communications, which stand in 3 different use cases and 3 different taxonomies. Free space optic, which is an outdoor communication point-to-point, and is already in place and existing, but mainly 2 other technologies that the Alliance is promoting, which is optical camera communications and Wi-Fi, which stand for light fidelity. Those two technologies have a very dedicated use case, and they provide very specific technologies and advantages for each of them. The added values for light fidelity, as I explained earlier, we are a non-radio frequency layer of communications. We use light, and the light waves are basically sending Morse code, an optical code, at a very high frequency, and this allows you to create a wireless communications network. But this brings a lot of advantages as well. The first advantage is the data security. The reason behind is radio frequencies go through walls, light doesn't. It's a very tight beam, and it's a very physical beam, which means that if you are not physically inside the beam, you basically can't intercept or jam the signal. Having non-radio frequency allows us to also be in locations where there's sensitive building or issues such as hospital. I will explain a little bit more about the use cases of light communications. And it's also using an infrastructure, as I explained, which is LED light, which is already in place and is known as to be one of the most energy savings lighting fixtures as of date. We also work with universities, and we have very well-known companies and universities and professors inside the Alliance that already work for the next generation of light communications. And as you can see on the graphic, we have already dedicated that light as a very bright future for ultra-secure light speed communications with very low latency and high reliability connection network. And as we know it, nothing is faster than the speed of light. The reason why we are providing that technology is that we saw that there is a need to support the development of technologies, and 5G is here for that reason as well, that you need to provide highly reliable, secure data or very ultra low latency. New services that 5G is promoting need to be supported by the additional of a new layer of communication, such as light. In order to be able to work with that, we work also with institutes, such as governmental. We work also with operators. Orange is one of us, and they are physically present here. And we work also with private clients who also need, for their specific use case, light communication benefits in order for them to reach their KPIs. We work on the standardization process with the Light Communication Alliance, and we work alongside the ITU and the IEEE. We have work group inside the Light Communication Alliance that are studying the implementation, as I explained earlier, on the standardization process through the IEEE and the ITU. So as of today, two promising standards has been established and has been highlighted by the LCA, which is the IEEE G9991 and the IEEE 802.11bb. As we explained, light communication can serve some very specific use case and some very specific purpose. For example, in hospital, which is a very established use case, you need to be careful of radio frequencies. Sometimes it's actually even forbidden in some of the places of the hospital. However, hospitals have a need for very ultra low latency and very high data rate, sometimes for even imagery, 8K images from radio. And now we even talk about remote surgery. And those critical use cases requires low latency, well, very, very low latency actually, and highly reliable data connectivity because it's a matter of life or death. We also work for smart cities and the Industry 4.0 who also have very specific needs, needs that requires the services of tomorrow, such as V2V or V2X, which is vehicle-to-infrastructure or vehicle-to-vehicle communications, which are also things that are coming in the near future. Optical camera communications is a unidirectional system that allows, as of today, low data rate connectivity from an LED light to a smartphone. The smartphone camera, the CMOS sensor, which is already built into the smartphone, acts as a receiver and has the capability to decode a unique identification number through the light and allows new opportunities such as indoor positioning system, ultra-accurate centimeter accuracy, or ultra-physical geo-contextualized information. For example, an example is a museum. If you go to a museum today, you do have an audio guide. And the audio guide basically provides you information based on your whereabouts. The exact same things can happen on your own smartphone, where the lights can provide you a code attached to a media that will be received onto your smartphone directly through the camera. We also work inside the LCA with roadmaps on the adoption and the market next generation of the technology and where we want to be on the long term of the technology. So we already have established different roadmap on services as well as on technological advancement. The market perspective that we are talking about is around $10 billion by 2025. So as you can see, the possible outcome of light communication is massive. It's a huge market that the light communication is promoting. And we already have partners and vendors that have already worked on specific use case and even adoptions. For example, aeronautical. Aeronautical is definitely another use case that makes a lot of sense because when we go to an airplane, some companies are providing connectivity, but that connectivity is not the easiest way to provide because of the weight capability of the plane, the cost that is related to it, but also the bandwidth because you have a lot of density of data that needs to be provided through a small location, which is a plane. But you have lights above your head, and in that particular case, this is why, as you can see on the slide, tests have already been provided so that you can keep high connectivity inside the airplanes. As I explained earlier, light communications is a new layer of communications that works alongside other technologies. We want to work with Wi-Fi, we want to work inside 5G with other technologies, and we believe that light communications can actually provide also its own benefits due to its physical attributes. And the help for being more sustainable or having to provide the continuity for better communications for tomorrow should not come at our own expenses. And for that, any new technology that we can provide, such as light communication, that can help energy savings, health, or sustainability, should actually be welcome, and this is the role of the LCA for that. And we have use cases, as I explained earlier. So hospital is one of them, Industry 4.0, smart building, banking. Obviously, defense makes also a huge interest for light communications because of the, well, as we understand, communications are key in military, and if you get jammed or detected, then again, some of our partners have already worked on that and already signed agreements with different military organizations to be able to look at light communications. But also some buildings with very particular means, just as nuclear power plants, as I said, hospital, and V2X and V2V. The perspective for light communication are strong, as I explained. We work also with some of our partners, such as Nokia Bell Labs, in order to integrate Li-Fi into 6G as well. The light communication has a bright future, as I explained earlier, with micro LEDs, and this is thanks to our universities and professors inside the Alliance. But it's one of the technologies that really could help providing answers to problems that we've been discussing during those 3 days, which has energy, secure of data, quantum key distributions, and bandwidth, which is mainly why we are here today. We also are open to new members. Any members can join. We're receiving requests on the website, and I'll be happy to discuss with you if you want. And for those who physically attend today's conference, and if you want to experience OCC and Li-Fi and see a little bit from your own eyes what we are talking about, I invite you to go to the Orange stand, one of our funding members, who has kindly demonstrated Li-Fi on their stand, and on the 4th of October, opened the first international shops equipped with Li-Fi and OCC demonstration in Kirchberg. And this is one of the first, and this is also one of the things the LCA wants to promote, is mass adoption by demonstrating the technology. It's not hypothetical, it's not theoretical, it's really practical, it's available, and it's available for demonstration right now on the Orange stand. Thank you very much.
Thank you very much, Marc. Just come a bit over here because I have one more question that I would like to ask you. I remember that when you're buying a computer game, very often you have, at the beginning, you have a message that you should be aware that people who are in risk of having epileptical crisis, they might have problems. What about now in this case here? I mean, you're emitting a lot of light at a very high frequency. Are there any issues, health issues that might be on the horizon, or is it something which is completely harmless?
Thank you very much. This is something that some of our partners, for example, such as Orange, have initiatives to work with the French AFNOR in order for that to answer all those questions. And some of our partners have already proven that it's actually totally harmless. This is absolutely non-intrusive. We're just using the visible light spectrum. The frequency is higher than the human eye, so basically you don't see it blink, you don't see it, you don't see the flickering, you don't see the lights going, and it is totally harmless because it's too high. And we work on our partners, and our partners are working on. We already have, even though the Alliance exists since 2019, most of our partners inside and founding members inside the Alliance have been working on the technology for the past 10 years. So we have even in R&D more than now 10 years of research and development in that, and that was one of the use cases that people wanted to fix. And as I explained earlier, Orange is working with AFNOR, and there's been no communications, and we've been tested and proving that there is absolutely no intrusion. This is harmless, and this is just light pulse. So it's optical morphs basically, and that's it, nothing more.
Sounds like an absolutely exciting technology. Thank you very much, Marc, and a very warm applause virtually and from here from the room for you. Thank you very much. Dear all, we are almost done, but now I have the big pleasure to welcome on stage a very special person. I would say he's the man. He's the man behind connecting tomorrow. He's connecting us to tomorrow with a conference, and therefore I think he's somewhere there hiding in the shadows. No, not yet. Eric, can you join me on stage, please? You are more than welcome finally to be on stage with me. Just for those who don't know Eric, he's from the SMC, and he actually is the main organizer of this conference. He's the one who's pulling all the strings and who has control over everything and who's kind of the mastermind behind.
Thanks, Vita, for such an introduction. I must say you did a great moderation so far, but on this one you were wrong.
I'm wrong. Okay,
I'm
that's the last proof that
I'm going to explain you why. So first of all, since you have been working that long, and indeed today was actually also quite a tough day about the connectivity, there is a reward for you.
Thank you very much. Helps a lot.
So for all of you who did moderation, I think a sip of water helps indeed for the tongue. And then now it's my turn to indeed, well, close this event as of this morning. There are going to be the workshops in the afternoon that you're going to present later on. But indeed, looking back at those 3 days, as you said, connecting tomorrow, yes, it's an idea that we had in our team, where indeed we were brainstorming about how you name such a thing, where we really want to show the added value of connectivity. We went all through COVID, we went through all the restrictions that we had, and we discovered that technology is there to help us as a citizen, as family members, as also then, of course, the workers who are working at an administration, at a private company, as a researcher. So this is how we came up then with the word of connecting after all tomorrow, because we cannot stop at where we are. We saw that there is need of doing more, and this is why this conference came in quite handy. A conference which actually was planned to have taken place in 2020, so it took place this year. On the first day, indeed, we called it Enabling Greater Connectivity. I mean, you could hear from all the speeches, including the workshops in the afternoon. It was really the day where we had a speech about the verticals, about all those sectors which pick up technology to use it for their benefit, and in return, of course, it helps a mobile operator or a fixed operator to much better understand what is the need of the citizens, of those customers, of those clients, who after all also then pay a subscription fee to have a quality service. Which also helped us to discuss about that there is a new relation between all those which normally would be the tech people to just sell something and be happy that indeed they get some money in return, but it's really about a shared understanding of what are the needs, how can you adapt it to the needs, and again also about us as a customer then, be it then a business, an administration or individuals, to also ask simply to the network vendor, please, I need a specific service, it's not there yet on the market, so we can actually claim new services, come up with new ideas and develop them. So that was the first day, and indeed all those who were involved there did a great work. On the second day, indeed, we really focus on the sustainability of those networks, because indeed, as I just said, those technologies are there to serve us. So what is then greater than really also showing that, yes, it does consume energy, yes, it does use resources to build those apparatus, but at the same time, it is there to help lives. If you look at all the things we discussed about e-health, it is there to give us greater commodity. So yes, we can travel, and while traveling, we are mobile, we are connected, we can exchange communication. So you could really see also about all those examples that were presented here, and again also discussed in workshops. It is, after all, really serving the society, but we have to use it wisely. We have to also decide about, indeed, when we use it and what we use it for, because resources, after all, we could see it also this summer, are limited, and we have to take care about what we are doing. Finally, today, so it's easy to wrap up the last day. You all have been attending it, online or here at Kirchberg. So it's really about then also showing that there is this beyond. We just heard about Li-Fi. We heard a lot about 6G today. It's very important that indeed today, here in Luxembourg, but also elsewhere in Europe, around the world, the researchers, but not just the researchers, also, and this was a feedback I got also from the regulators that you heard here in the morning, of Alexander, of also Eric, is that they are now the ones to gather information, intel about what do you think you need in the future, what are your dreams, your hopes, be it as a citizen, be it as a business, be it us as a government, what do we expect already now from a 6G, because they need time, and that's a long timeline from now to 2030, they need time to prepare it, to standardize it, that if it's working properly, it's working worldwide ideally. We know that the mobility will remain, after all, a constant being of the human being. So this is what is very important, I think, as also a small homework that you all can take and go back home and give that message back to regulators, to also industry members, who then again also will be in the process of what you learned this morning of setting up the next standards. Well, I almost forgot, of course, quantum communication infrastructure, where you could also see that we already, as a small country, quite involved in it, and also I will invite all the other countries to also pick up on those challenges which are linked to the future technologies and the communication that we will need for the next decades. Very important for us also, I will just wrap that piece of paper away. I mean, you had quite a big audience, and I think the speakers also did this challenge, accepted this challenge and did a great work. We, on purpose, deliberately, we really chose to address both the citizens to really understand, to show what this is about, at the same time that all the people who are working on projects, communication projects, they could come up here, they could understand what is the technology about, and take it back to their teams, share the knowledge, and also explain the greater good of what they are working on. Also, especially on the first day, but also today again, I could here see many people from what you call the C-level, to really also, it shows that communication, like IT in the past, security, is not anymore just something which is done just like that as a background job. No, I think people realize it's very important that on the top level, you are aware that you need a good communication, that you invest into this communication, and that you also support the people in your teams who are taking care that every day it works fine. So thanks for this very mixed audience, very participative audience, and not to forget, on the citizen level, we had very, very active students who came here yesterday, who listened to the speeches, who also had a very, very, very active participation in the workshop, a long one, over 3 hours. They worked heavily on indeed their vision for the future. So I think already for those youngsters, you could really give them a warm round of applause, because some of them even come back today and will join the workshops in the afternoon. Not to forget, I said there's a homework, so please help us spreading the message. If there's anything they would like us to improve next time, there's things that maybe didn't work out that well, please share with us, the team of the SMC. If there's anything good, please spread it to the outside. I think this is something where you can still access the archive of the conference later on. Please review it, leave your comments, share it with the outside world, because indeed, I think many more people can learn from what has been told today and over the last 2 days. Thanks then, because otherwise we as a SMC with our team, we wouldn't have been able to do it properly. So a big thanks to all the speakers, please, of today and of the previous 2 days. And of course to all the workshop leaders who also did a great work in the afternoons to really engage the participants of their workshops. So the workshop leaders, a warm round of applause as well for them, please. What was also great was that today and over the last 2 days, you could really touch, you could see telecommunications. So we had an exhibition area which was really showcasing what communication is about. So thanks to all the companies, administrations, researchers who were here as an exhibitor. So thanks, and also for keeping it quiet while the presentations went on over here. So big round of applause also for the exhibitors. And now comes the more tricky part. I hope I really don't forget anybody. Such a conference, yeah, and that's where we were wrong. No, it was not Eric himself and alone. There was a big team behind, so thanks to everybody involved. Starting with the venue, so the team of Lux Expo, and of course that we could have all the technology right up and running, so to Codex and to Freelance. So Freelance is a company, not just a status. So thanks to those two companies who helped us greatly to put all this on stage and online. Then to continue also, we have a company called Presence. They helped us greatly to also manage this online platform and to do the translation. So thanks a lot for the French and the German translation all over those 3 days. Last but not least, also to have a better documentation about the event, we had a team of 101 running around here to shoot movies, to take pictures, so thanks a lot to them. The pictures are already spreading around, so please grab them on social media and spread them further. A whole team of Concept Factory, a communication agency which helped us greatly also about the general concept of the event and a lot of things that happen in the background so that you indeed could be welcome today over here. About the speakers, there's after all one specific partner that I would like to highlight. It's the European Commission with their teams from both DG Connect. You had 3 speakers over the 3 days that are really, really helpful also because they are working in Brussels effectively that whatever then there is as a service, as a policy, is then in place European-wide. So thanks to the staff of DG Connect, but also DG Reform. actually, there was a project that was also visible yesterday and the day before in 2 workshops that were organized by a team which is around the project that we call 5G Lux. So the 5G strategy was actually launched 3 years ago in Luxembourg. And at that time, we said that we are up and running. We have pilot projects that were visible over here, but also we have an additional team then who worked on really complementing the strategy. So behind this team, I would like to thank the team of Everis, of Insights, and of List, because they really helped us diving deeper into the strategy, working in the background to really get this ecosystem of 5G up and running, to also show in a much more effective way which are the actors. So we did already events over the last 2 years. But again, I think a nice highlight was the 2 workshops they did yesterday and the day before. So thanks also to that team. They did a great job over the last 2 years. Thank you for the applause. So I could indeed and also sip some water. And then finally, of course, there is this team of the SMC, which was here actually on so many different levels. We had the team of Renita up there. We also are involved ourselves behind the Lux QCI project, so thanks a lot to the people involved in this. We had the team working on the broadband strategy, so great to have it published here by the minister on Monday. And they're waving down there. Thanks a lot to all the team up there. We, of course, then had the workshop about the youngsters, where then is in the frame of the Digital Skills and Jobs Coalition. So thanks a lot to the team behind that one. The team of Digital Luxembourg to also help us spreading the message in the most possible ways. Sorry, it's not COVID, it's just a dry cough. Yes, and then, after all, I know it's a team effort, but really very important. There are 4 people I need to mention because they did a lot of efforts over the last, not just weeks, but months, to get it up and running as of today. So really a big warm applause, please, for Ben, for Anne, for Natalie, and for Christian, because they really worked hard. They really worked hard to make it happen, so thanks a lot. It was really a great effort, and I think content-wise it really paid off. Please help spreading the message of what they have prepared over the last months, because it's really nice content, and I think you can all benefit from this over the next months. And then last but not least, there were 2 people who helped us then, after all, that all the things worked in a good way over here on stage. So there's Magda, who helped us really then also that the speakers found their place over here. Thanks a lot for that. And Peter, thanks a lot. A very warm applause to Peter.
Thank you. Thank you. It was not a work. It was a pleasure for me.
That we could see. Thanks for having the pleasure, but still doing it and also with us. And so warm applause to you. And then I give back the floor to you, because indeed you will announce then also the workshops of the afternoon. So thanks, everybody.
But before I'm going to announce the workshops, indeed, still, Eric, you are very modest. But nevertheless, a great team is not working without a great leader. And you have assembled a team which is making a tremendous job. And I can see it because I was involved in the preparations. I was working with the people. And I must say, Eric, you have created a team. You have forged a team that worked together in such an efficient way that it was from A to Z. It was an absolute pleasure working with you. And this applause now, Eric, is really for you for making this happen.
I will take it back to the team. Peter, thanks a lot, and let's have a look what's going on in the afternoon.
Absolutely. We're not done yet, so nobody moves, nobody goes away. Virtually nobody disconnects, because we have at 2 o'clock, we have workshops. I'm just going to go through the list. We have the workshop at 2 o'clock, 5G and microwaves. Eating is before. The microwaves are not used for eating anything, just to be aware, even though it's the Luxembourg Science Center who's going to make this workshop, host this workshop. And from my own experience, if there is anything with the Luxembourg Science Center, go for it. It's interesting, it's spectacular, it's something there you can learn quite a lot. Unfortunately, only for those who are here, because you need to see it virtually doesn't really work. Nevertheless, for those who want to connect virtually also, as well at 2 o'clock, the 5G for satellite and terrestrial services. How is virtualization transforming the ability to respond to rapidly changing user demands by SES? And then again, all the other workshops are virtual and in person. Augmented reality and 5G, perfect match for future B2B use cases by Telindus. Again at 2 o'clock, indoor PPDR coverage by SMC service Renita. 1535, workshop empowering rural communities and digitalizing agriculture with 5G, SATCOM, Internet of Things, and cloud technologies by List. Again, 335, workshop SNS, Sense the Nexus Symphony, public investments in 5G plus 6G with a new funding landscape by Lux Innovation. And then 1535 again, workshop unmanned aerial vehicles and 5G by SNT. That's it so far, and well, this means also that my job, my pleasure has ended. The only thing that I can say now to all of you, those who have been here in person, those who were behind your screens, a very, very, very warm thank you from my side for being with us here. It was a pleasure for me. I hope you learned as much as I learned also. So many things that I have discovered, so many things that I have learned. And I can only say one thing. I'm very happy to connect to tomorrow, because tomorrow looks very interesting and extremely, extremely challenging on one side, but challenging in a good way. Our life will be different in 10, 15 years. And it's going to be more in the background where the things are changing, but we're heading towards a very interesting life, and I'm looking forward to it. And I hope to see you again, maybe next year, for the next conference. We don't know. I didn't speak with Eric yet if the next edition is already in the pipeline, but I bet that he has already something that he's working on. This said, thank you very much. Enjoy the rest of the days with the workshops. It was a pleasure being with you. Thank you very much.